Hi viewers, this is Sri Ramlu. My YouTube channel is yes.yes space physics. So please subscribe it before watching this video, and don't forget watching this video till the end. So today's topic is Carnot's engine, and sometimes we call it is a Carnot heat engine also, right? Okay, friends. A heat engine is a device convert heat into work, right? So Carnot engine definition he is saying. What is the definition of the Carnot engine? A heat engine is a device to convert heat into work, right? A device which converts a heat into work, that is called Carnot heat engine. This engine cannot be realized in actual practice. That means this engine cannot be prepared, cannot be utilized, cannot be manufactured in real life. Okay, actual practice means real life. However, this can be taken as a standard. However, this can be taken as a standard, but it is a ideal for all the devices, right? It is ideal for all the devices which perform an actual engine can be judged. The engine is shown in figure, right? So here the diagram is given in this diagram. So like this only heat engine can work, and it has certain parts. So what are the parts it has? Let me explain. It consists of the following parts. What are the parts? It is hot body maintained at a constant high temperature. Okay, so there are the three parts: source, sink, and substance, working substance. Among them, source is what? It is a hot body maintained at constant high temperature. So this always maintains a constant high temperature, and let its constant high temperature is T1 degree, T1 Kelvin. Okay, it has a very large thermal capacity. So that means it has very large thermal capacity. Okay, its thermal capacity is very much high, such that if certain amount of heat taken out from the source, its temperature should remains unchanged. So it has high thermal capacity means if anyone gives a temperature to it, or anyone takes a temperature from it, then it cannot change. So its temperature cannot be changed. Its temperature always constant, even though if you take heat energy from the source, or if you give the heat energy to the source, then its temperature remains constant, means cannot be changed. Sink, it is a cool body maintained at constant lower temperature, right? Source means that is a hot body. Sink means cold body, and it also maintains a lower temperature, constant lower temperature. Let its constant lower temperature as T2 Kelvin. It absorbs rejected heat. So that means the sink can absorb the heat given by some other body, or given by the working substance, or given by the source. Okay, rejected means it absorbs, it takes. It has very large thermal capacity. Same like this, it also has very large thermal capacity, such that if certain amount of heat given to the sink, its temperature should remains constant. That means anyone gives a temperature to it, then its temperature cannot change. Okay, so here also if anyone takes a heat energy from it, then its temperature is constant. If anyone gives the temperature to it, then also its temperature is constant. Okay, next, working substance. Third one is working substance. A material which absorbs heat from the source, rejects a part of heat to sink, and converts remaining heat energy into mechanical energy. Right? Here, working substance means what? It is a material which absorbs heat from the source. Right? It takes heat from the source. Right? And a part of this heat, what it can do? A part of this heat can convert as a work. Okay, only part of it here source, and rejects only part of it can gives to the sink. Okay, working substance part of it gives to the sink, and the remaining work what it can do? So convert remaining work, remaining heat energy into mechanical energy. So from this it takes heat energy, the part of heat energy given to the sink, and the remaining heat energy converted into mechanical energy. So according to diagram, see here, it is a source. So from the source, working substance is taking Q1 amount of heat energy, right? So its temperature is T1 and let its heat energy is Q1. And what it will do, part of this Q1 can it convert into work. Why? Because it is a working substance. So part of heat. And the remaining heat given to the T2. So giving a heat is called Q2. So giving, so here we do not use word giving. So what we use? We use the word reject. So part of it reject to the sink, right? It takes Q amount of heat energy, which one? Working substance, and convert the part of heat energy to work, and the remaining energy give to the sink. Okay. So while it is taking heat energy from the source, then source temperature cannot change, and while it is giving to the heat energy to sink, then also sink temperature cannot be changed. So work is what, it is Q1 minus Q2 is what, simply work. How much energy is given to the sink, and the difference is what, it is a work. So next, working. So how does it works? That is, let me explain one by one. Every heat energy, every heat energy, the working substance absorbs. Okay, working substance absorbs. So main work of the working substance is to absorb the heat energy. Some heat from the source. Okay, so some heat from the source, from source it takes heat energy, some certain amount of heat energy, and I reject to the what, part of this heat energy to the sink. Okay, that means it cannot, working substance cannot use total heat energy which is taken from the source. Only some part may be used as work, and the remaining given to the what, it is given to the sink. That means it is rejected to the sink. Convert remaining into useful work, and returns to initial stage in a cyclic process. So there is a general on cyclic process. So there actually there is no syllabus, so that is why I didn't give it. Okay, next, a continuous mechanical energy is obtained from the heat energy, right? Continuous mechanical energy is obtained from heat energy due to the repetition of same cycle cyclic process again and again. So if a heat energy gives, so work substance take heat energy from the source, okay, and convert into work, and the remaining heat energy gives to the sink, and from again it takes heat energy from the sink, and given use part of heat energy to work, and given to the source. So that means it takes always cyclic process like this. Let amount of heat absorbed by working substance from the source at a temperature T1 is Q1. Yes. So just now I explained you. So Q1 is what? It is heat energy of the source, and it is temperature of the source. Heat rejected by the working substance to the sink at temperature T2. Okay. So heat rejected by the working substance to whom? Sink. So rejected means here heat given to the sink. At what temperature? T2. How much amount of heat energy it reject? Q2 amount of heat energy. Net amount of heat absorbed, dq is equals q1 minus q2 here. So how much it is taking from the source and how much it is giving to the sink, if you take their difference, so it gives net amount of heat. Okay, let initial internal energy of the working substance is ui. So working substance internal energy is ui, and the final internal energy of the working substance, let me take it as uf. Since during each cycle, working substance return to its initial state, hence change in internal energy is zero. That means, suppose it is what? This is a source maintaining temperature T1 and heat energy is Q1, and amount of heat energy given by working substance. Amount of heat energy taken by the working substance from the source, and give it to the part of heat energy to the sink. Okay, at a temperature T2, and heat energy is Q2. Now again what happens, it takes reverse in direction on some certain amount of heat energy, and gives the same amount of heat energy to the source. That means that this process takes continuously. So from which state it is coming, again reaching to the same state. So that is why no change in internal energy will occur. So difference of internal energy is zero. No change means zero. Let work done by heat engine during each cycle. So it is what it is, thermodynamic first law. Okay friends, first thermodynamic law, first law of thermodynamics. So first law of thermodynamics is what, dq is equals to du plus, actually it is a dw, but here not, we are not taking dw, we are taking w. So that is instead of dw, let me write simply w only, and here du value is 0 according to this one. And a dq, we know dq means difference in heat energy is what it is, q1 minus q2. So q1 minus q2 is work. So like this, work is the difference of two heat energy. Next, efficiency, it is important. It is defined as the ratio of work done, that is w, work done w, by heat engine during each cycle to the amount of heat q1 absorbed from the source by the working substance. Okay friends, what, ratio of work done, ratio of work done means w by the heat energy during the cycle, each cycle. 2 means here indicates division line. Amount of heat is q1, here q1 and here work. So write here w value and write in denominator q1. So it is efficiency definition, qw by q1, where q1 is a heat from, is heat received taken from source, and w we know, just now we have seen w is what, it is above, see here above. So above w1 is this one, w is, so substitute w value here and I write. So this is a formula, efficiency formula in terms of q, and efficiency formula we can also write in terms of temperature, 1 minus T2 divided by T1. So don't forget, this is also important formula in terms of temperature. It is in terms of heat energy. Efficiency formula in terms of temperature is 1 minus T2 by T1. Okay, next, Carnot's theorem. So that is, above one is Carnot engine. It is theorem. According to this theorem, no engine can be more efficient than reversible engine working between the same two temperature. Here, according to this theorem, no engine in this universe, there is no perfect engine which works more efficient than the reversible engine. So reversible engine is the most efficient engine in this world. That is the meaning of this one. Okay, working between the two temperatures. This may also be stated as all reversible engine working between the same two temperatures have same efficiency, whatever may be the working substance. So here not, no importance about the working substance, whatever our working substance you take, but what, all the reversible engines working between two temperature is always having the same efficiency, no change in efficiency. In order to prove this theorem, so that means above one, in order to prove above one, let us consider reversible engine R and irreversible engine I. So for reversible engine I have taken R, and for irreversible engine I have taken I. Why? Because here I is there, in irreversible R is there. Okay, working substance with the same source and sink. So no, I'm not changing source and sink, I'm using always the same source and same sink. Here I works in forward direction, while R works in backward direction. So that means, suppose for example, I works, if I works like this, then R has to works in reverse direction. Or if I works like this, then R has to works in reverse direction. Okay friends, now let engine I absorbs amount of heat, that is a Q from the source, convert a part of it into work. So here what is taking, let irreversible engine is absorbing the heat, how much, q, from whom, from source. So it is taking q1 amount of heat, from the source, and convert a part of it into work. So part of work converting into, a part of it is converting into work, and transfer the balance q minus w to the sink. So it is transferring the balance, what, that balance is q minus W, to whom it is giving to the sink. Okay, next. Similarly, so about this one over, it is a irreversible engine. About reversible engine over. Next, what is doing reversible engine? So reversible engine has to work reverse. Reverse means it is taking heat energy from the source and giving heat energy to the sink. But what it has to do, it has to take the heat energy from the sink, has to give to the source. That is important. Reverse. Similarly, let R absorbs amount of heat Q dash C. Heat is absorbing from where? From this one. How much? That is a Q dash. Q dash from the sink. So from sink it is absorbing a certain amount of work. W dash is doing. So it is converting the part of heat energy into W dash. A work is done on the working surface and transfer the net amount to the Q dash plus W dash. So net amount, remaining amount is transferring to whom? That is Q dash plus W dash to this one. This Q dash plus W dash is what you know, that is the Q. Okay, so that means Q dash plus W dash is Q. Where is here? Let me show, that is also here. Right here it is giving Q dash plus W dash to the source as a Q. So from this working substance, bring this is this side, Q minus Q dash. So it is a part of heat is converting into work. If possible, so I'm understanding, if possible, let means assuming if there is a chance, let irreversible engine I is more efficient than reversible engine R. For example, what I'm saying, irreversible engine is having the more efficiency than the reversible engine. Then what we write? So it is a definition. Definition is what a reversible engine or anything efficiency formula is work by heat, right? Work by heat. So for irreversible, W by Q. For irreversible, for irreversible it is for a irreversible W by Q. For reversible W dash Q dash by Q. Why? For all reversible engine, here for all irreversible engine, so what I am using, without a dash I am using. For reversible I am using the dashboard, here dashboard and here also dashboard. Okay, so that is why it is this one. If leave these two, so that it is a greater means that this work is must be greater than this work. I'm right. Let it is equation number 1. Now imagine that two engines are coupled by a belt in such a way that heat that engine I works directly and it drives the engine or reversibly. Okay, suppose these two are connected by a belt like this. How it is appearing? See, if these two are connected by a belt in this manner, belt, that means here only this one can rotate. So with, if there is no belt, so this one can rotate. If because of connecting belt, if this rotates along with this also rotates. Now imagine that two engines are coupled by belt. Okay, it is that the compound engine extract amount of heat Q minus W dash from the sink and gives amount of heat to the source, amount of heat Q to the source. Here what, while it is driving, so it takes a heat amount of heat, this much amount of heat, and give to the part of it converts into work and the remaining amount gives to the source. Therefore the net amount of heat, net amount of heat from the sink is, so from the sink is here, it is given by the irreversible and it is given by the reversible. Okay, it is for irreversible given by the irreversible to the sink and it is given by the reversible to the sink. Sorry, it is taken from the sink, so it is given to the sink, it is taken to the sink. Then these two gets cancelled and what you get, we get, if we multiply minus it become plus, so that means it come for first side and then it is minus. Am I right? I think you are understanding this one. Okay, now let is equation number 2. The equation 2 is positive according to equation 1. The above fact shows that by coupling engine the heat absorbed from the sink Q minus W dash. Once again, the equation 2 is positive according to equation 1. Why according to equation 1 it is positive? Here what this is, see, it is a W is greater than W dash. That means this value is greater than this value. So this value is more, this value is less. So more minus less is always positive. So that is why it is positive. The above fact shows that by coupling engine, the heat absorbed from the sink is greater than the heat given back to the sink while the source is unaffected. Here what? Heat absorbed by the sink is greater than heat given to the source. So this value is greater than this one. Work done, work done, and no change may be left. Work done and no change may be left with the source. This is impossible according to second law of thermodynamics, which states that it is impossible for any device to extract heat from a simple reservoir and converting the whole into work. What is saying that it is what heat absorbed. This heat is saying greater. This heat is what? Heat is heat taken from the sink, but actually sink is in at a lower temperature, that is a T2 comparing to the source T1 temperature. So how can we take the more heat from the low temperature body, and how can we give the heat to the high temperature body by from the receiving the from low temperature? It is impossible. Actually we cannot take heat energy from the cold body. Low temperature body means cold body. Why? Because sink maintains low temperature. So here heat is this heat is greater we are seeing, and this heat is we are seeing lesser. That means the heat is taken from this, so sink is greater. So but actually sink is a low temperature body, so we cannot take a heat more from the low temperature body. So that is why the this one is wrong according to second law. So it is impossible to the second law. According to second law of thermodynamics, which states that it is impossible for any device to extract heat from a simple reservoir and converting the whole into work. So actually it is not possible. Okay, so by absorbing heat energy from the sink and giving to the source. Hence our assumptions that irreversible engine is more efficient than a reversible engine is wrong. So what we assume here? Here we assume, if possible, reversible engine I having the more efficiency, so that it is cannot have the irreversible engine more efficiency. It is always having less efficiency than the reversible engine. So that is easy. Hence our assumptions that irreversible engine is more efficient than reversible engine is wrong. Thus, no engine working between the source and sink can be more efficient than reversible engine. Anything which are working between the source and sink, they are not more efficient than this one. They are always less efficient. Okay, so this is the things, friends. Don't forget watching this video till the end, and don't forget this formula in terms of temperature. Why? Because many problems comes on this formula only, right? Thank you, friends.